All right, the last bit in chapter 2 that we want to study, we're going to study section 2.5, which is all about the equations of lines and modeling using lines. We want to talk about the point-slope form of a line. We've seen the equation y equals mx plus b. This is our old friend, the slope-intercept form. Slope-intercept form gives us m, the slope, and the y-intercept, 0.0b. So we can see m here and b hanging out there. We can also write the equation of the line as ax plus by equals c. This is the standard form. We actually don't use this too much. We will use it a little bit in chapter 3. Not as useful as slope-intercept and the form that we study next, point-slope form. This is very useful to us. Point-slope form of the equation of a line takes the following form: y minus y1 equals m times x minus x1. You can see the slope right here again. There it is, m. The point in point-slope form, that's the point x1, y1. So that is our point in point-slope form. The x and the y in point-slope form, those are variables. We don't touch those. They just kind of hang out there. All right, let's use the following example to see how to use the point-slope form of the equation of a line. Let's say we have an equation. It has slope 1/2, and it passes to the point 3, 8. Let's find its equation, and we'll use y minus y1 is equal to m times x minus x1. We can start plugging in the things we know. Well, y1 is going to be 8. Right, the y coordinate of the point on our line, I can just put that in here for y1. That is equal to the slope. Well, the slope is here, given to us as 1/2. I can just put that in. Times x. X is just a variable. I won't touch it. The ones without a subscript, those we do not touch. And then I will put in x1, x1 being the x coordinate of the point that was given to me. That's 3. This would be the point-slope form of the equation of this line. I can just write that as y minus 8. Y minus 8 is 1/2 times x minus 3. Point slope. We can change this to slope-intercept form. In fact, we can simply solve for y. First thing I will do is distribute this multiplication. I have a multiplication here. I can distribute through the parentheses. That'll give me 1/2 x minus 3 times 1/2 is 3/2. Should add 8 to both sides. To clear that up, that gives me 1/2 x. Well, I'm taking a negative 3/2 and adding 8. I guess I should do some side work here to figure out what that is. That's 8 minus 3/2. I'm dealing with 8/1 minus 3/2. I'm adding fractions. In order to add fractions, I need a common denominator. The common denominator I'm going to choose will be 2. I'll use 2. In order to get 8/1 to be something over 2, I will simply multiply by 2/2. Multiplying by 1. 2/2 is 1. Multiplying by 1 doesn't change anything, so it's a valid thing to do. We'll say 8 times 2, 8 and 8 is 16, and that's over 2. So 16/2 is the same thing as 8, and now I have a common denominator. and I can carry out this subtraction. 16 minus 3 is 13, and then that just goes over 2. So negative 3 over 2 plus 8 comes out to be 13 over 2. And this would be the slope-intercept form of the equation of my line. So slope-intercept form here. These are both valid. And unless I ask for a specific form, either one would be fine. All right, we have another example here. It says find the equation of a line passing through these 2 points, the point negative 1, negative 3, and negative 4, negative 9. Now I need to know what the slope is in order to get the equation. So let's go to our slope formula. And find the slope of this line. So we said our slope formula says my slope is y2 minus y1 divided by x2 minus x1. And we can decide, we don't need to worry about which one, but we can just let that be 1 and let this one be 2. So I pick out y2. y2 appears to be 9, negative 9, excuse me. So negative 9 minus negative 3. I'll use parentheses so I don't make a mistake here. And then x2 is negative 4 minus x1 is negative 1, parentheses. Why the parentheses? Because negative negative gives me a positive, so that turns out to be a negative 9 plus 3 and a negative 4 plus 1. Negative 9 plus 3 gives me a negative 6 and a negative 4 plus 1, a negative 3. Perform the division. I will have negative 6 divided by negative 3. That becomes a positive 2. So the slope here is a positive 2. Once I have the slope, I am in good shape. I can use either form that I want. I can use the slope-intercept form or point-slope form. They both work. You may choose. Because it's relatively new, let's try out point-slope. It says y minus y1 is m times x minus x1. I have another choice to make, which point to use. For no particular reason, I'll just grab this one. So that becomes y minus, what is y1? It's negative 3. We'll put that in parentheses. M, we just found m, it's 2. It'll be times x minus x1. x1 will be a negative 1. I will use parentheses. And then I can carry out all of these operations. That becomes a y plus 3. That is 2 times, that's x plus 1. Carrying out that multiplication, that's 2 times x, which is 2x. 2 times 1, simply 2. Last thing I need to do if I want this in slope-intercept form is to subtract 3 from both sides. Subtracting 3 from both sides, that's a plus 2 minus 3 over here. That's y equals 2x plus 2 minus 3 is a negative 1. So both forms here are correct. They have the same line. And I don't mind which one you give me unless I specify. And we just need to be careful of wording here. So I have a note for you. If it asks for a linear function, if you're ever asked for a linear function, we actually do care what form it is. That means slope-intercept form, because functions are written as f of x is equal to blah, 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 some stuff, which means that the equation will be solved for the dependent variable, the y, or the f of x. So if you're asked for a linear function, that does imply that we want slope-intercept form. Otherwise, either form of this line, it's the same line. They're both correct. So since both forms are correct and valid, it sort of begs the question, what's the better one to use? And it really depends on the situation. So looking at the next example, notice we have been given the slope and the y-intercept. If we're given the slope and the y-intercept, well, seems to me that slope-intercept form might be the better choice. Slope-intercept form says y equals mx plus b, where m is the slope and b the y-coordinate, of the y-intercept. Well, I was given the slope. There it is, -4. And I was given the y-intercept. The y-coordinate of the y-intercept is 7. I can simply write it down. So if I have been given the slope and the intercept, in fact, slope-intercept form is the way to go. And there we have it.